Okay, hello, great audience. I'm sure you are. Anyway, the original talk was about Agile, but I was doing another parallel talk about it and felt this talk might be better for the programmers of the world. So we tried it out in Bucharest 2 weeks ago, and programmers liked it better than Agile talks and things like that. So hope you like it. The slides are down there at my website if you want to dig them up sooner or later. Power to the programmers. Okay. I have a bad habit. I like really slides filled with text and facts and examples and experiences. And a lot of my friends say, oh, you can't do that, Tom. You must have color, slides, one word, things like that. And I say, but then it's not real. So think of it, my slides, as being a page of code. You know, we can handle that. But this is a page of code usually at a higher level, looking at maybe the architecture of the systems. So now, if you really must have something simple, I did a TEDx talk, and they forced me to be really simple with few color slides and not to speak to my geek friends, as they said, and things like that. So if you really want something simple, you can always download this for 17.5 minutes. How to quantify the unquantifiable. Didn't you always want to do that? Okay. I have to confess, I'm an ex-coder. Spent many years of my life doing that, kind of fun in my youth. But I finally figured out there was a higher purpose. If you like, managing and controlling and architecting the coding and the coding environment. And so that's what my talk is about, that higher purpose. Maybe some of you would like to move up to that. It's not necessarily a better place, but it's a different place, and somebody has to take responsibility for it, or we will be doing excellent coding for the wrong things. Okay, so that's me as a young coder, about 6 years old. Okay, here's the summary of the whole talk. Maybe I can summarize even better orally. I believe that when programmers are empowered to do the design, they do it much better than the architects can ever do. I believe that when programmers are empowered to design their own working environment, they can do it much better than any managers can ever set up. Okay, and I'm going to document that with facts and examples. Okay, so maybe you'd like to grab the power, and because that's best for all parties. Okay. Here I am being really irritated at my architecture friends in London, about 300 of them, because I have never seen anything I admired in architecture. It's all a bunch of nice sounding words, no responsibility for the cost or effect of what they do, no involvement in the daily grind of turning out the system. And so basically I told them they're a bunch of idiots. But if you want the full 1 hour story, if you have some architects you'd like to bash a little bit, you can get the video there. But this is a sample. I said, if you have 300 architects in the room, IT architects, and I said, how many of you, when you specify an architecture, specify the cost of the architecture? Sometimes these costs are, you know, £3 million or something like that. And the answer was 3 people out of 300 put up their hands. That's like not taking any responsibility for your ideas. Okay, and it gets worse, but you can see the whole talk. I think they are an embarrassment to the community, but they probably get paid more than the programmers. Okay. Now, so here's how we're going to do it. But basically, at the level of the projects you're working on, I believe that if programmers are given numbers for how good the system's going to be in qualities, performance, and cost, then the programmers as a team can make decisions about the right designs to reach the qualities, performance, and cost better than any architect can ever do. And they can code their decisions, and they can measure their decisions the same week and find out whether the decisions are good or bad, something the architects cannot do. Okay? And I'm going to give you examples of some of my clients who've been doing this for over 10 years at least. On the second subject, what we found is that when managers try to design an environment, this could be what tools are going to be used, what frameworks are going to be used, what office cubicles are going to be used. They invariably do a pretty bad job, maybe because they don't have to suffer the same bad decisions themselves personally, I don't know. But history has shown that when programmers take over the power of deciding about their own environment, all the physical details and the tool details, they make much better decisions, and you can measure that their productivity will go up by a factor of 3. For example, bugs will go down by a factor of 3. I'll show you examples of this. So there's every evidence that programmers can handle the task of designing their own environment much better than anybody else. Okay, so that's the talk in a nutshell. I'm going to start off with 2 case studies, and then I couldn't resist this picture. It takes a while to absorb, but you'll recognize yourself second from right. So anyway, but I'm going to give 2 case studies, one from Raytheon and one from IBM, and this is about designing your environment, really. Okay, first. So the basic idea is we need to get away from the idea that some managers, architects make decisions on how we're going to work, top-down command and control, okay? And we have to put ourselves in the loop of looking at what is causing us to do bad work, what in fact is causing us to do good work. And we need to spread the good stuff and get rid of the bad stuff. And there may be, for example, I have an example at IBM in a 2-year period, over 2,000 changes to the environment. Not one big change, like now we're going to program in this new programming language, okay? But, and very many of those changes are physical environment, noise, heat, space, okay, distances, communication, stuff like that, just to make it more physically comfortable and less disturbing. You know, get people off your back so you can concentrate on your task. So that's the basic idea, the shift from top down to we're in the loop making the decision and verifying the decision that the way we want to work is a good way of working. I'm going to do a case study, which if you want the details, those are the things there. The main drivers of this process are known as defect prevention process and document inspection. Now, document inspection, if you like, you want to call it a code review, that's fine, but it means people reading code and maybe inputs to coders like requirements and finding defects, faults, bugs, and that sort of thing, and then analyzing them, and that's the defect prevention process. And the analysis is pretty simple. What is basically causing this to happen? Is there a root cause that we can change so it doesn't happen 1,000 times tomorrow and 1,000 times tomorrow and 1,000 times tomorrow? Okay, and then that grassroots insight, if it's correct, and you make the change, will switch off a flow of defects caused not by the fact that we're bad programmers, but we're like given bad information and bad tools and bad timing, whatever the cause is. So that's basically what's going on. Now here's a high-level view. At the beginning, this is Raytheon, and they had 1,000 programmers, and they're programming software for the Patriot missile, the intelligent missiles. And the left axis there, that is percentage rework. So rework is dealing with bugs and problems and retesting. Okay? Now, it's at 43% when they start. So that means there are 430 programmers fighting their own bugs. So imagine an army of 1,000 brave soldiers, and we're just about to go to war, and the bad news is that 340 of them are either tending the wounded, they themselves shot, or they are shot. And the rest can go to battle. Now that's a pretty stupid army. I mean, you know, enemy shooting you, that's one thing. But you shooting yourself and putting half of your army out of commission, that's really stupid. That's who we are. This is a normal number. If you don't have a number, if you haven't measured it, you probably have something like 40–50% rework. Just fixing your own stupid faults. Of course, not because you are stupid, but because you have had a bad working environment that forced you to commit these errors and bugs. Anyway, there's a theory from a guy called Philip Crosby, who wrote a book, Quality is Free, and a later one called Quality is Still Free. And his theory was this rework is not necessary. It's not a natural thing. It's natural if you don't do anything about it, but it's not natural. You can get rid of it. You can change the environment. And as you see, the curve, moving down in an 8-year period down to 5%, they got rid of, they reduced this by 10 to 1. And in the first year, they reduced it to 27%. So they saved 130 people in 1 year. What they did in the first year is they said, you will follow the standards for programming, which are well intended. They may be bad, but you will all follow the standards. That is, each individual cannot make up their mind about what standard they'd follow. Okay? The standards were awful, but they were better than chaos and everybody making their own personal decision about, coding standards and things like that. Okay? So they, by simply following the standard, they got to what is known as a stable output of where they, if they didn't change anything and they all followed the standards, then for the next several years they'd all have 27% rework, or 270 people out of commission. But at the moment they got this stable process, they can do systematic process improvement, so the curve starts going down, 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 because they are now doing the defect prevention process. They're analyzing bugs from tests and analyzing bugs from code reviews, and they're finding out what is the root cause of these, what are known as common cause. There is a common root cause bugs, and they're removing the common root cause that forces the programmers to commit bugs, and getting better and better and better and better. Okay, so this is a very clear example of, and it is the programmers doing the analysis. What's wrong here? Why is it bad? What should we do better? And installing the changes and measuring them. So this is, in a sense, proof that it takes a while. There's no instant fix. There's no one great magic silver bullet here. But if you work at it, you can reduce the things that cause people to do bad work, because they're not bad people. They're just given bad inputs, basically. In the same study, they showed that the productivity of the programmers, in terms of outputs, went up by a factor of 3. Okay, so partly that's because they're not wasting their time fighting the bugs they put in, and partly they've got better processes in place that make them more productive. So you can roughly triple the productivity of programmers by this process. Not bad. And of course you should get triple the pay, right? If you triple your productivity, just think about that for a moment, at least. Okay. Now, when they started off, they had a 40% budget overrun. Have I got this right? Yeah, 40% budget overrun. In the first year, when they started stabilizing things and improving things, the budget overrun went down to 0, and it stayed there. In other words, they're not running over budget. Okay? How many people have ever had a project that cost more than was originally estimated? Yeah, I thought so. This is how you can crack that problem. Okay. Here are some examples of process improvements. What do you think they had to change? Well, the usual stuff. You see, stuff about bad interfaces and integration and test, stuff about test repeatability, stuff about bad code review processes, stuff about bad requirements, and things like that. Okay, the usual sinners that give bad inputs to programmers, basically, one way or the other. So these are just practical examples of what we say a process change that people figure out they're going to do. This kind of stuff. There's quite a variety of it. It's just anything that's stopping you doing good work. Okay. This, by the way, is the bug density curve, and so a bug reduction by about a factor of 3 over time too. Not bad. Okay, that contributes, I'm sure, to the productivity and to the reduction in rework. At a political level, which probably doesn't interest you very much as a geek, but might be worth noting, they figured out fairly early that every dollar they invested in making this process better, the return on investment was $7.70. Now, how much are you getting from your bank account? What, 2%? 3%? This is 770% return on investment. Now, you might not be very impressed by that, but your chief financial officer, who might give you funds for changing your environment and making everything much better, they're very interested in this. They would love to invest in anything this glorious. Okay? So you say, oh, we don't have the money, we don't have the time to change. You're joking. It's the best investment the company's ever had. Okay? In fact, in this study, they said, because we could present the fact that we had a huge payoff from doing it, we got all the money that was going around for improvement, and other people didn't get it because they didn't make the same argument. They may have been doing equally good work, but they did not make this argument, so they didn't get their money. Okay, so you might learn to talk to the guys with the money. They will empower you to do great things. Okay? There's just a map of the process. We're not going to go through it in detail, but you'll study it. There's a lot of literature on this. Basically what's going on is that the programmers are analyzing their own bugs and their own specification defects, i.e. requirements and design defects. They're suggesting work environment changes, okay, that they believe will reduce the problem, and they're verifying and measuring that these are working. If they're not working, they take away the bad stuff that doesn't work. And so they're reducing the rework by a factor of 10. Okay, power has been delegated to the programmers, and it works. And this is a simple proof. Here's another case. This is this time from IBM. In 1970, Ron Radis, who co-invented inspection and software inspection, and also invented the capability maturity model, he's still very much alive and well, and Michael Fagan, they invented inspection. Their idea with inspection was to gather data so we could analyze what was wrong and make the process better. But it didn't work. It didn't work for 10 years. And I didn't know why. I was involved, and Fagan didn't know why. And but looking back, we know the reason now. They had managers should manage. You know, that the manager is in control. There was no idea of delegating any power to programmers. And that's why it didn't work for 10 years. Okay. So 10 years later, along comes Robert Mays and Carol Jones at IBM Research Triangle Park. In my book, there's a chapter by Robert Mays explaining his methods. And he had this great idea of delegating power to the programmers to analyze it, not to the managers, right? And it worked, okay? It worked so well that he got a prize from the chairman of IBM, big diploma, I think $100,000 for this great invention. And this is the same defect prevention process I showed you working at Raytheon. It's the same but yeah. Again, we had 10 years of learning that managers aren't very good at managing this stuff, but when you delegate the power and information to the grassroots, it works a heck of a lot better. Yeah. So here's one of my clients in London who was following this whole idea. And in this case, they had so many defects when we met them that they were going out of business. They were going to fail. So we had a crash program, but it still takes a long time it takes years to really change a culture so you get much better. But we took the model of Raytheon, in fact, and said, let's do something like that. And this is their actually bug reduction curve, very dramatic first for the major defects, which we've focused on. And but long story short, they're using exactly the same techniques of delegating power to the programmers and analyzing what's wrong and changing things. Okay. Actually, in this particular case, it's kind of funny. There were about 60 programmers to begin with. 30 of them didn't want to do code inspections or participate at all. They just said, my code is my code. Nobody's going to look at my code. It's perfect anyway. And so they were considered non-team players. And they were asked if they'd like to find another job where they could just do their code all alone. So they left. There were 30 programmers left. The 30 programmers then got so much better in quality that these guys took over the market and won. So they could do better with 30 cooperating team programmers than they could do with 30 other programmers who just weren't going to play on the same ball team. Okay. I asked Dick Holland there, what did you do with the money for the 30 programmers who left the company? And he said, I gave it to the first 30 who wanted to play ball, so they doubled their salaries. I asked him what happened to him in his career. He said, my salary tripled as a result of doing miraculous things like this. So there's a payoff in leading the change there, which Dick did. That's a recent photograph this year of Dick holding a guest lecture at my courses in London. Okay. Here's another example. This is at Douglas Aircraft, and we're not doing code at all there. We're doing engineering drawings for aircraft, okay? But it's the same thing. There are faults in the drawings of the aircraft, and we're measuring them using inspection. So we find, for example, here's a real single case study, but it's representative of hundreds of engineers going through the same thing. We have an engineering drawing, and we find 80 major defects. Let's just say, call these bugs for the moment. They're as good as bugs. And we then say, well, we have an exit level. You can't have more than maximum one major defect before we release your drawing. So you have 80 times worse than you're allowed to have, so you can't exit. Up to that point, they've always been allowed to exit. So it's garbage in to them maybe, but garbage out to everybody else, and everybody else is forced to commit errors. But we stopped that with an exit level. We measured this. And then so for the first time, they have to focus on, well, what are these rules and standards that I have to follow, and how do I follow them? And they start learning. So they submit something else that they think is clean, but they still have 40 left. What's happening is they've learned a little bit of how to follow good practices and recommended practices, but not enough. So they still fail. And then third time around, the same thing's happening. They're learning, they're measurably learning how to do good practices, but they still fail. Okay, fourth time around, still fail. Okay, fifth time around, 0. Okay. Now, it turns out this learning is now more or less permanently embedded if they can remember the practices. They now are practicing at a more professional level without maybe going through 10,000 hours to do it either. Okay, this is actually going through a few weeks of learning. What we discovered was that if you set a standard and you measure it, you will motivate people to learn excellent professional practices. Okay, and they will get 100 times better. And we did this with first 300 or 400 engineers at McDonnell Douglas, later expanding to the 3,000. Later we did this at Big Brother Boeing, same thing, which is still in place. The method is called PEP, Process Error Prevention. So this is quite powerful stuff. So this is not, we're not changing the process, we're changing the individuals by motivating and measuring them against a standard of professional conduct. That's what's going on. Here's another view of the whole thing. If you look at the various history from IBM, NASA, and others, what we find is if we use this defect prevention method that Mays and Jones did, then in the first year of using it to analyze what's wrong, let's change stuff, then 50% of all the defects that are normally committed historically are gone. Okay? Well, still 50% left. As you do more and more process improvement through the years, for example, in the second or third year, 70% defects don't happen. Not that we find and fix them in test, they don't happen ever. The error is not committed. That's the best of all, because it cannot delay you, you cannot fix it and have regression test problems. Stuff like that. At the outer limit at NASA, they're reporting defect prevention levels 99% and higher than that in time, but it takes years to mature the process. Now, what is not prevented hopefully gets detected by early stage stuff called inspection, code reviews, requirements reviews. So the major advantage of those reviews is that the cost of fixing a defect is about 10 times less than if you find the same defect in test. Okay, so you save time and you save money. So, and again, you can find certain percentage of stuff, but never all of it. So then the column that says test there, that's now we're testing, now the bug is in there, and now we're going to find a certain quantity of the bugs. And what we don't find, of course, goes out to the famous user. But this gives a perspective of all these technologies sort of cooperating and doing the best they can, and then some other guy takes over and tries to do a little bit better. Okay? But unfortunately, we have too many environments that are mainly relying on test, which is too late, too little. They're not preventing the thing from happening. They're not finding it early in inspection. They're testing badly. Test is about very roughly 15 to 55% effectiveness. That is, it'll only find about half of the bugs that are there anyway, any known form of test. Okay? There are, I refer you to Capers-Jones for lots and lots of statistics on how bad test is at finding defects. Okay? Several of his papers are up on my website for free download. Okay. Now, here's some experiences from IBM in Minnesota, where Mary and Tom are from, and from Research Triangle Park in North Carolina. The best, of course, is in Minnesota, Mary, right? Let's go Minnesota. But, yeah, the thing, various data here. The thing I like to highlight is that in Minnesota, they had between, let's see, in a 30-month period, they had 2,162 changes. to their environment. Okay? This is not one big new framework or new programming language or some big idea. So managers always come up with the big ideas that don't work. You know, they may even be good ideas, but they're then poorly implemented. Okay? Programmers come up with really practical ideas that they would like to see because it'll make their life better. They actually choose smart stuff. And it turns out it is the many small changes that accumulate and give a good effect. Big changes. Tom Peters wrote many a management book with the same theme. Big management ideas don't work, and small evolutionary steps get the job done. So it's really the same thing going on here. Yep. And again, the return on investment for doing this, the defect prevention process, is somewhere between 10 to 1 and 13 to 1. So it really pays off to invest the money, but you do have to invest some money, but you get pretty good results the first year, and then it takes several years to maximize your ability to get results. So in the scorecard, managers 0, they totally fail, and developers 1. Okay. And directors, etc., or that level should not design the work environment, and developers should involve the environment through their practical grassroots, in the trenches, insights of what is happening. So now we're going to shift to a similar but different subject, where we're going to talk about devolving the power of design from a level of architect or manager to the developers themselves. Here's first level of development. I want you to do all my worrying for me. So now, so the left-hand side is what we don't want to see, is various people in power at high levels, but who are abstracted from the reality of the everyday work, making decisions, this, we're going to do this, and we're going to do that, and that's our working environment. We need, again, to get the, working environment, and that is what you're going to code. That is the product that's going to go out to the user and customer. What we need to do is get the developers in a loop where they're in fact taking over the power of design, which was previously done by managers, users, customers suggesting what the design should be. A lot of amateur design are called requirements, but they're not really requirements, they're actually done. If somebody says, I want a password, they're actually designing bad security, and they have not actually got a clear idea of how much security they want and that kind of stuff. But the programmer's told passwords. The programmer says, I can program password, and they're all done. Okay, but they're programming a bad design by a bad designer, an amateur who doesn't understand that maybe a password isn't the smartest thing you can do for security. Okay, so yeah. Okay, so we want to put the programmer in the design loop. Okay, now you do that by giving the programmer a superordinate set of objectives, like we want the usability regarding training to go down from training 3 hours down to training 3 minutes. Okay, there's a very clear idea of use. It's a measurable idea. So the problem for the programmers is, what is the design so the training goes down to 3 minutes? Okay, and then they get an idea and they try it out, and maybe the training goes down from by 50% of the way we need to get there. Say, oh good, that works, but we don't have enough. So what's the next idea? And so programmers keep on coming up, brainstorming, literally, ideas they think would meet the usability targets, or the security targets, or the performance targets. And it turns out the fact that they can actually program the answer in detail and actually measure it the same week is very powerful. And they actually understand the innards of the system. Is something that architects cannot and do not do, and managers cannot and do not do. So they're actually better at designing than any manager or director or architect ever was. So here's a case study. This is a client of ours. We started with them in 2003, so that's 11 years. They're still going strong. There's our hero, Trond, who he was actually the test manager, QA manager, but I think he had 3 testers, and the total quantity of developers was exactly these guys, their real photo. They were, so there are 13 developers and 3 testers. Okay, but Trond led the change. In that picture, you also find the guy's chief architect and founder, Petter, is right in the middle, just below the, well, in the middle, we'll say. enough. Okay. When we met them, they had a sort of a startup, but it had been going 8 years, and they had a lot of famous customers, and they had half the world market, which is pretty good for a little Norwegian company. Okay? Half the world market for their product, which was Gallop poles and stuff like that. And however, they had a not unexpected problem. They had a hell of a technical debt. They had a legacy system. They'd just been hacked together with no particular grand foresight into how to make it easy to maintain. And so it was terribly difficult to make changes, but the competition was in there building new stuff from scratch and getting a clean start, and so competing with them. So they said, we're a dinosaur. We won't be able to compete. So they were very, very interested in improving a whole lot of characteristics of the system. In the very first instance, they wanted to improve the usability from having a 1-week course to use their product to 0. Then they could sell 1,000 times more, Boeing and Microsoft told them. So that was their initial focus when we met them. Now, here's an example of setting an objective that the programmers will respond to. So this is one of their usability objectives. It has a scale of measure. They're trying to reduce a 65-minute task for their users down to 25 minutes. So this is using my planning language, which allows you to specify qualities in a very intelligible, quantified, and testable manner. And they had about 35 of these all told when they started off. And they took the 35 ideas of how good we're going to be by the next release, a quarter of a year from now. And they literally divided them into 4 parts and gave them to teams of about 4 programmers, or 3 programmers and a tester, more likely. This just says they're shifting from looking at use cases and functional requirements and that level. They're actually gone to a much higher level of thought of how good it's going to be. And they said that detail of what the design will be, we're going to delegate that to the programmers themselves to figure out and test. Okay? So in a sense, they've wiped out the conventional burndown stack of 1,500 requirements in a queue forever. They did that quite consciously and said, we're going to look at this from a higher level perspective of the 25 most important things for our customers every quarter of a year. Here is one of the teams of 4 people. This is a snapshot of their work on the 9th week. They're doing weekly cycles for 12 weeks, and then on every quarter of a year they're releasing to the world market their product. Okay? Every weekly cycle, the programmers are challenged to do a design, find a design themselves, no interference from anybody, not even their chief architect, Petter, the founder. And they're going to code and implement continuous integration, all that stuff. And then they're going to measure either themselves or independently how effective their design was. So let me give you a detailed example of that in a little. If we take the example where we actually saw that, if you look at the bottom there, it says usability.productivity, okay? And the pass level was 65 minutes. That had been there for every customer having to spend 65 minutes on this task every day kind of situation. They wanted to get it down to a tolerable level of at least 35 minutes, at least about twice as good. And ideally, they had a goal of getting down to 25 minutes. Can you see that under the big word target? Okay. So this is now at the beginning of step 9, the 9th week, if you go to the percentage improvements column, and maybe I should be a little bit more helpful and point that out here. The number here was 0. In other words, in 8 weeks of work, they had done nothing for this and accomplished nothing. So they said they have several choices, several powers here. And one is they can choose which one of these to work on at any week. So they said, we choose usability.productivity because it is 0. So they have a stand-up meeting for about a half an hour, and they brainstorm about 12 ideas for how to get from 65 minutes down to 25. So this is the degree of improvement, moving from the pass level to the goal level. And amongst the ideas was an idea they called recoding, which was market information recoding. I thought for years it was something like recoding the code, but it was just marketing codes. Anyway, everybody who suggests an idea has an obligation. Unlike my architects in London. they have to estimate how good their idea is, in this case recoding, for saving the minutes. And the guy who suggested recoding said, I think it'll save 20 minutes. So here we have what's called the real estimate of 20 minutes. This was the biggest number suggested of any suggestion. And they also said it'll take 4 days to do it. That's the 4-day cycle there. So we can't do anything else, and it's the best thing we can do. So let's do it. So the team breaks up after half an hour and said, we are committed to implementing the logic for recoding the marketing codes. At the end of 4 days, they shipped it out to Microsoft usability labs, who had kindly said, we will measure all your usability stuff for free for you. So they shipped it to Seattle overnight. And back came the answer from Microsoft. This change you made saved 38 minutes, which is 95% of your goal. Trond, who I showed you a picture of, he said that 95% isn't good enough. He talked somebody into spending a weekend to tackle the problem of getting to the goal of 25 minutes. To get to 100%, in other words, and he actually got down to 20 minutes during the weekend, which explains why they achieved 12.5% more than they needed to achieve accidentally. Okay, so you begin to get a picture of this loop. It's a very clear high-level requirements coming into the programs. They know exactly what the task is. In this case, reduce the minutes. Okay, it's up to them to figure out how to do it. Nobody is interfering with them. No salesman, no customer, no architect, no manager. They said, you guys figured out, you are the best to figure it out. They've trusted them. They've been doing this for 10 years now. Okay? And so they figure out the best they can figure out, and then they code it, integrate it, test it, and even hand it over for external testing, and find out whether their idea is any good or not. Okay? So now, by the way, this is a snapshot at the end of step 9 out of 12, 9 weeks out of 12. Now, if you look here, you'll see the percentage achieved of their goals. So this goal is halfway achieved. This is all achieved. This is twice as much as you need. This is nothing. Nothing. That's good because they now have week 10, 11, and 12 to work on the nothing goals. So one of their prerogatives is to decide which goal to work on. They get a little bit of help because there's a little computation here using the numbers here where red means, you have a problem, Houston. You better prioritize this because this is at 0. Yellow means you have achieved the tolerable level, so that's good, but you have not yet achieved the goal, and that's not good. And green means you have achieved the goal, in this case 100%, and therefore relax. Now these signals are used to give, I call them dynamic prioritization signals. They're computed based on what's going on, measures every week, and they basically allow you to know what you should prioritize, which is what you haven't done a good job on, quite simply. Okay, and you should not prioritize any work on that job which is already 100% done or more. So it turns out that these teams, I think I have a kind of such a big screen, maybe you can actually read it for once. But these are the 4 teams working in parallel, approximately 4 programmers or 3 programmers and a tester on each team. And if you look at that column of progress to date in the 9th week, you'll see that they're ahead of the curve. This is the new Burndown Chart. Okay, so they are approximately at 91% of achievement in 75% of the time. Okay, that's ahead of the curve. But this is a Burndown chart, not about we wrote the code and it's tested. This is a Burndown chart saying we have delivered the value to our customers. It's in the system we will release now, and it's proven. Okay, that's a much bigger achievement in writing code that does not deliver value. Okay, at the extreme, if they found a way of doing this without writing code and they delivered the value, that's fine too. They're totally free to figure out what to do. Okay. But you can see these teams are succeeding wildly. They're way ahead of the curve. And so normally every quarter of a year they achieve all their targets. And it's partly we delegated the power to choose what to work on. So they work on the problems that aren't yet solved and how to work on it. We figure out the design, we code it, we test it initially, we get it maybe externally tested, and we follow up every week. So we don't need a project manager breathing over our shoulders saying, you're late, you're late. Okay? We know if we're late, but if we got 91% and 75% of the time, we're not late. We've already succeeded wildly, and we have 3 more weeks to goof off. Okay, so I once asked the question: what if everybody reached 100% in 9 out of 12 weeks? You know, aren't you going to give them a 3-week vacation? Well, I don't know. Life isn't so kind. That should be the reward, right? If you get the job done and you have weeks left to release, you should get vacation paid. Or maybe, if not vacation, I'm in one organization, we tried to do that. And they said, that's just not going to happen. We don't do that. Everybody else would get so jealous of the programmers getting all that free time and vacation. What we can do and will do is say, they can have training of any kind they like. We'll fund it. And they did that. It was a British company. Okay, so you don't have time to go on training. Okay, but what if you finish your work early? No problem. Go on, get better training, upgrade your skills. Here's the cycle of work. The left-hand side, we developed at Hewlett-Packard, who did our EVO. This is our agile method called EVO. Did our EVO method very well, hundreds of projects, 2 master's theses we have studying it. But this is just, you know, what happens with the development team, what happens with the users. These guys innovated and said, this is what happens at the system, the corporate architect level, the founder, Peter, and the right-hand column is what's happening with the test and quality assurance interaction. We're not going to go through that in detail, but it's just nice to see the cycle of work and how people are synchronizing it. Now, hidden in this cycle is actually 1 day of refactoring. They said, we have this huge technical debt, and said, why don't you use 1 day every week to refactor? Okay, turns out they did that, but it didn't work very well. I don't know how many people tried to do refactoring, but it didn't quite work the way you hoped or imagined. I've got a follow-up story about that in a moment. Here's some of the results they got in that first quarter. These are the 5 most sensational improvements, and they are quite sensational and non-trivial. Every one of these is something a user can touch and feel, and users were ecstatic. These guys went on to wipe out their competition and buy them up. They were so good in quality. Okay, and none of the competitors had any idea what was going on, why these guys were suddenly getting so good at delivering a product that everybody wanted and nobody wanted to have any other product. Another good sign is that the developers love this, and Trond put a name on it. He said, it opens up for empowered creativity. Okay? And I'm hoping some of you would like to be empowered to be creative, and that's more fun than just writing code that somebody else has told you exactly what you're going to do. Okay? So I guess there are 2 types, those who want to be told what to do and don't want to be responsible for creativity. How many of you are here? You just want to be told what to do and you don't want to be responsible for creativity. Okay. How many of you would like to be creative and find great solutions and designs? Oh, wow. Okay, there's hope for Poland. Okay, because that's what we need. Okay? And the fact that the developers loved the method, they embraced the method. Okay? I have this Rodin statue of the embrace. It's called the kiss, and I'm always amused when people say, "What's that got to do with it?" Programming. I said, "No, they embrace. This is a programmer embracing a method." In case you didn't get the simile there. Yeah. The initial customer feedback using it on the survey tool was that their customers were delighted, to put it mildly. Okay, and now the second round of doing this, we got the data for. The marketing director decided we wouldn't give real numbers because that would tell too much to competitors, so they just gave percentage improvements. But look at the non-trivial large percentage improvement. This is a quarter of a year, again. And they're cherry-picking the things they need to get better. Intuitiveness of the system is increased by 175% in the second quarter, for example. The actual measuring idea is there in the description, by the way. What does that number mean? And there's a second page of this for the second quarter with some more non-trivial numbers. Okay, so it's amazing the quantity of fantastic stuff you can get and prove you got, and which customers realize you got when you use this method. Now we asked the question, why didn't they do this before? And the simple answer is nobody ever gave them a clear number and said that's our goal. You know, it just said, let's play ball, but there was no scoring mechanism there. So people didn't reach for it, and they weren't empowered to reach for it either. And so nobody cared. So for 8 years, they're bumping along with legacy systems and bad systems, because nobody's ever given them a stretch goal and say, let's go where no man has gone before us, and let's do it as a team. Which, the moment they're empowered, it works magnificently. Here's another case study. This is looking at technical debt, but we're going to meet our friends again 2 years later. I'm just looking at some technical debt paper that I read just before I held the talk by this guy. And he's claiming all these, well, this is conventional refactoring, okay. And he says, well, the main thing is that you impact on some qualities. The qualities would be maintainability, adaptability, portability, things like that. But so here are his claims about how all the wonderful things are impacted if you do refactoring. However, notice something. There are absolutely no numbers to support any experience or case from him or anybody else that refactoring does all this wonderful stuff and how much it does. This is what I get really tired of at conferences, hearing all the nice sounding words, but no evidence whatsoever of how it worked for the lecturer or anybody else. Okay, so I would enjoin all other lecturers when making claims to back it up with some facts and numbers and not just claim it. I've already seen too much of that here. And I'm fortunately going to fly to Budapest about 12 o'clock, so I won't have to suffer the rest of it. Okay. So there's a smarter way. Anyway, here. So in 2005, Trond showed up at a conference in Norway and said, we just decided to dump that idea of yours, Tom, that 1 day a week refactoring. It wasn't working. We weren't getting any measurable progress. But we had learned that this idea of setting quantified goals and then allowing our people to design towards them, that works really well for the customers. And we thought, well, wait a minute, there are some other stakeholders here, and there aren't customers. They're us, the developers and testers. So they decided to turn their attention to themselves, a little bit selfish, 1 week every month. And they called it the Green Week because they're improving the programming environment. And what's the deal? They make a list of the things that they believe need to be improved. You can read the list on the right and get an idea. They put some numbers on it and they said, right, for a whole week, we can design our own environment. So this is not totally unlike the defect prevention process. It's just the defect prevention process is more analytical, find root cause, change stuff. This is proactive design, to design the programming environment so that it's better. It's another way of doing process improvement. Okay, but the sexy thing here is they're designing low technical debt into the system. The refactoring, if you think about it, is just messing about with the code, but it doesn't mess about with the test processes or anything else. There are lots of things that refactoring doesn't solve in the development environment. So these guys have a holistic attack. They're saying, these are the things that worry us currently, okay? And they're putting numbers on how bad it is. They're saying they're putting numbers on how good they want it to be. And then they are designing their own environment. And they are changing their own environment. It's a little shop, little Norwegian company. And they are measuring that they get better. And they do that. They have a guarantee. You do this for 1 week, have fun, your environment will get better. And then you have to turn your attention to the customers for 3 weeks. But after that, you get back to yourself. And by the way, this investment in refactoring, you're happy because it makes your work environment better. But fact is, we can get changes and improvements through to our customers much faster because you did that. So win-win for everybody. Smart idea. You ever had that resistance? Well, we'd like to invest in better stuff, but right now we have some customers, screaming at us, so we don't have time to do it. Okay. This is the argument: is this investment makes it better for the customers too. Therefore, it's a smart investment. This is almost world history. Developers engineering a better development environment, and they're doing it on a regular basis. Okay? Amazing stuff. So this is just a summary of that process, and this just points out their green week existence, right? 3 weeks for the customers, and then turn attention to themselves, 1 week for them. Amazing idea of a rhythm there. So conclusion, we can tackle technical debt in a much more intelligent way. By the way, definition of intelligent, you see, these things here are a definition of the technical debt problem they have. And the numbers attached to those are a definition of how bad the technical debt problem is and how good they want it to be. Okay? So, how to measure technical debt, it's right there. It's tailored. It's their problem. You may have different problems. Make a list of your problems and how bad you are and how good you want to be. And then let your team loose to engineer and change your environment and test and measure that indeed it's getting better. What a fantastic idea. I wish I'd thought of it. I can just observe my client was smart enough to do it, and I was smart enough to capture the idea and tell you about it. Okay, but I didn't invent it. Okay, so yeah, working in. Now I'm going to introduce to you briefly. Don't have much time. We have enough. There's one of the finest development environments ever in history is known as the Cleanroom Method. Now just let me test. How many people say, I know what the Cleanroom Method is? I've read about it or something. There's a hand way in the back. And that's it. Wow. You know, Santayana once said, he who does not learn from history is doomed to repeat it. So if you don't learn what the Cleanroom Method is, you're doomed to waste your time and do bad projects for years until you figure out what they figured out. So I'm your historian. I'm your white-haired, gray-haired grandfather. Okay, and I was there, and I knew these guys, and I remember what they did, and it's quite amazing. Let's take a look. Now, they worked on from 1970 to 1980. Harlan Mills had a job. He said how to improve the programming environment. So when they had a fixed price contract for space and military, the most sexy, difficult systems of all, right? Software. They always delivered on time, no penalties, under budget, a profit. You see, up to then, every project they'd done, they'd lost money and been late, like all other software. But for IBM, this was no. So IBM went to Harlan there. I consider him like Leonardo da Vinci of software, the genius. Really smart character, okay? I think I'm smart, but I think he's a lot smarter, put it that way. Okay? IQ 195 or something crazy like that. Anyway, wonderful guy. Now, he spent 7 years. He was empowered to find an environment where these tough contracts could be delivered on time, under budget, highest quality in the world, right? By the way, we're in the middle of the Cold War. Poland is our Warsaw Pact enemy, okay? By the way, once during that era, I was Poland got about $20 million to get external training courses from the West. Right? And I was part of that training course. So I came to Warsaw and Katowice and maybe one other town and was holding software engineering lectures. And I discovered that the NATO Science Council had funded the 68 and 69 software engineering conferences where the software engineering term was coined. And so just for fun, I also discovered they didn't charge for the conference proceedings, which had all the wisdom of large-scale programming. So I said, would you mind sending about 500 of those conference proceedings to Warsaw, to me? And they did. And I handed them out to my course participants and said, this is the NATO Pact's gift to the Warsaw Pact. Gee, must be, you're supposed to get a good laugh there. Maybe there's a reason for it. Anyway, they did. So we transferred that technology as well as we could. Hopefully to some people who became your professors or something like that. Anyway, without going into detail, what they're doing the same as my evolutionary delivery. They're doing the same as lean startup, but not quite as, they're doing it monthly rather than several times a day. They've got quantified goals, and they're going through cycles of putting in design and seeing how well it works, like does it get us to this availability for the piloting system and stuff like that. You can see, here's one real project, 45 incremental deliveries in 4 years. So that's once every month for 4 years. And that means they're going through a cycle and delivering and measuring what's going on. Now, in that particular project, every one of those deliveries was on time and under budget. The bottom line for all their projects, including space shuttle ground systems, very few late overruns deliveries in that decade, 70s, and none at all in the past 4 years. So here we are, 1980, we have perfect project management for the most difficult software projects ever. Okay? Now, all you have to do is replicate and there's no reason why your project should ever fail or overrun. But if you have not learned from this history, you are doomed to repeat the history that IBM had before, where they always ran over and always, didn't do a good enough job. Okay? So if there is by the way, this is, in case you didn't recognize, a very early Agile project, because that's exactly what it is. Okay, long before the Agile Manifesto, and much better than the crap in the Agile Manifesto. Okay, I have written extensively about my opinions about the Agile Manifesto, but problem is, it's a 3-minute warning. Problem is, the Agile Manifesto doesn't deal with quality and cost. It just deals with functionality. Okay. Now, there's a section here which I'd like to have time for, but I don't. But it's about a guy called Quinnen is writing about Robert Quinnen. He's doing dynamic design to cost. In other words, again, if you like, the programmers in the loop are designing and measuring their design. And that's one of the reasons they succeed. No time for that. And so we're just going to skip this lovely little example and get to the end. Anyway, I think if the programmers of the world unite and say, we're not going to ask you, we're going to take the power of doing design. We're the only capable ones around here. Okay? And we will prove by numbers that we do better anyway, and you'll be delighted to let us keep the power. Maybe that's how we're going to do it. So this is my last slide. If some of you want to get up to the next intellectual level of thought above coding and want to learn real software engineering, I'll give you a free copy of my book. But it's tough. It's only for intelligent Poles. Thank you very much.